We're asked to find the percent rate of change. The percent rate of change is just the relative rate of change times 100. Okay, so really similar to the other question that that I just made a video on relative rate of change. So you want to take a derivative. So we'll go term by term because the derivative is a linear operator. The derivative of x is 1, and the derivative of natural log of 3x, that's 1 over 3x times 3. That's what this notation is trying to tell you here. If you're trying to take a derivative of a natural log function, the chain rule says that you also have to multiply by the derivative of the innermost function, by that 3 that's in there. And so that just cancels out. So that's 1 over x. So anytime you take a derivative of natural log of 2x or 3x or 4x or 5x, the constant actually doesn't matter. It's always going to balance out to be 1 over x. So there's our derivative. Our relative rate of change is 1 minus 1 over x over the original function, x minus natural log 3x. Let me see what Newton has for multiple choice options. Here's the options they give us over here, and I forgot we're doing the percent rate of change. So this is the relative rate of change. The percent rate of change is just the same thing. Multiplied by 100. So it's 100 times this. And there's some algebraic reworking we can do. I'm seeing if we can avoid it though. Doesn't look like it because this doesn't match up with anything we have over here. So one thing you can do algebraically, you know what you could do? You could go to desmos.com/calculator, graph this, and then see which graph matches exactly. Okay, but the algebra way of rewriting this is that the numerator, you could combine like terms. I mean, you could get common denominators for these fractions. That's 1 subtracted by 1 over x. That's the same thing as x over x subtracted by 1 over x, right? And so that gives you x minus 1 over x in the numerator. So we have this fraction being divided by this fraction. So another way of writing that is like this. And so when you're dividing things, you can flip and multiply. So we get x minus 1 over x, and this is something over 1. So we could flip and multiply. That's 1 over x minus natural log 3x. And now you can just multiply straight across the numerator and straight across the denominator. So we've got x minus 1 in the numerator. In the denominator, we have x squared, because x times x makes x squared. And then times x, subtract x natural log 3x. Okay, now does that match? Not quite this one. This one. There we go. This is the correct answer.